Swayam Prabha. Digital India. Educated India.
I am Dr. Rajiv Mishra, working as professor in Department of Computer Science at Indian Institute of Technology, Patna. The title of today's lecture is Edge Cloud System Architecture, Latency Models and its Evaluation. So, let us get started with the introduction of Edge Cloud System Architecture. So, as we know that the number of Internet of Things connected devices and that the data which are produced by these devices has increased dramatically. Therefore, this would require some kind of offloading task from the low resource devices, let us see IoT device, to release the heavy computation and storage to the resource rich nodes such as edge computing and the cloud computing. So, this is a very basic fundamental. Let me outline this in a more details. So, as we see that these number of Internet of Things devices, they are producing lot of data and thereby this has increased the data, which is the data intensive nature of computation requires. Now, this particular amount of data cannot be processed at the IoT devices, which are resource constrained devices. So, IoT devices examples are, let us say that the sensors and actuators, and often they are called things. These devices are in large number operating and monitoring the environment and generating the data. Now, this particular huge amount of data which is being generated by these IoT devices requires a heavy computation and the storage. For that, it requires the help of or assistance of edge computing and the cloud computing for supporting this kind of applications which are called an IoT applications. However, the different offloading strategies often require a specific architecture of this edge cloud system, and this particular architecture will have different impacts on the service time performance for supporting the new kind of applications such as autonomous vehicles, then augmented reality application, which is also called AR, VR, online gaming and smart CCTV. So, these are all new set of applications and they are also having specific time performance requirements to support these kind of applications, and for them this edge cloud architecture will be a very useful paradigm. And in this particular paradigm, how different offloading strategies will be applied to support these applications. Therefore, this edge cloud system architecture is the point of discussion in today's class. So, in this lecture we will talk about edge cloud system architecture that can support the scheduling offloading task of such devices, which are also called as an IoT applications. The idea is that using this edge cloud system architecture to support the scheduling offloading tasks of an IoT applications will support the objectives of minimizing the enormous amount of data which is being transmitted in the network. Similarly, for the time performance measurements in the latency sensitive applications which we have already specified, that is autonomous vehicles, augmented reality, online video gamings and smart CCTV. They are all latency sensitive applications. So, to measure the time performance of these latency sensitive applications, we will introduce also the offloading latency models, and this particular model will be good enough to investigate the delays in different offloading strategies and schemes. And then this particular latency model for offloading latency models will explore the effect of computational and communication demand on each one. So, therefore, we are going to, if we summarize this particular lecture contents. So, first thing is that we know that how are we going to reduce this particular computational and communication demand, or considering that IoT devices are scarce. So, we are going to use the model which is called an edge cloud architecture. Then we are going to consider the latency models and figure out the performance of task offloading in IoT devices to support the latency sensitive applications. So, as you know that the edge system or edge computing system primarily deals with how are you be going to do this kind of latency support in these different applications. And so, around that we are going to express this architecture called edge cloud system architecture and develop the scheduling policies, mechanisms, framework, so that we can understand through the latency model whether this scheduling or task offloading for an IoT device will suffice the application requirements of latency sensitivity. So, all these things are going to be covered in this part of the lecture. So, let us get started with the challenges if you are going to support the latency sensitive applications. What are the challenges? So, the challenges are summarized or classified around two different issues. One is called the communication delay, the other is called computational delay. So, the delays which are incurred due to the computational delay and the communication delay to support the latency sensitive applications, we are going to minimize this overall computation and communication delay. So, let us see what are the different challenges are there in this edge cloud system and how the edge cloud system can support this delay sensitive application in terms of computational and communication delays minimization. So, starting with the challenges, we have to understand the applications. So, for example, in most of these new kind of applications, let us say self driving car or online video gaming or smart CCTV. In all these applications, we say that they are delay sensitive applications, and in most of these applications the important aspect is about the customer experience. So, customer will have a good experience if let us say a delay or the latency is minimized or reduced and yet the applications are supported. So, for enhancing the customer experience and accelerating the job execution, these IoT task offloading enables such devices to release the heavy computation and storage to the resource rich nodes in the collaborative edge or the cloud. So, that means that this way of enhancing the customer experience by accelerating the execution, task offloading is one of the important paradigm in edge cloud system. So, IoT task offloading enables these mobile devices to release the heavy computation and storage resource rich nodes in the collaborative edge and the cloud. So, as we know that the cloud and edge are having enough or enormous or the computation and storage capabilities. So, IoT device will often use the task offloading and thereby achieving this delay sensitive applications requirement, and therefore, by minimizing the computational and the communication delay. So, this is the challenge. The second important thing is the resource management in this environment, that is called cooperative edge cloud environment. So, this resource management often becomes a challenging because it deals with several complex factors. We are going to see what are those complex factors, why it is not that easy. So, additionally we are going to see that how different architectures and offloading strategies will impact the end to end performance or the time or the service time performance of IoT applications. Often becomes quite complex due to the dynamic and unpredictable assortment of the interconnected virtual and the physical devices. Now, thereby what we are going to see here is that all these latency sensitive applications have various changing characteristics, such as sometimes the computational demand is fluctuating and obviously the communication demand is also fluctuating. So, this particular environment will achieve this latency sensitive applications requirement, and this is the point of challenge which we are going to cover in this part of the lecture. Consequently, the latency often depends on the scheduling policy of the application offloading tasks, as well as where the jobs are to be placed. Where means we are now seeing this kind of model, that is called edge cloud model. So, in the edge cloud model you have here the IoT devices or just simple devices which are connected devices. These particular devices often offload their task. Why? Because the computational resources are not available with these devices. So, either they will be available at the edge or they will be available at the cloud. So, this particular kind of architecture will give the edge cloud model. Now, coming up the scheduling or the task offloading. So, the IoT or the devices will offload the tasks to support the latency sensitive applications. So, it has to now understand the availability of the resources, whether it is available at the edge, which is very close by to the devices. So, the latency can be minimized. If not, the resources are available at the edge, then it will take the help of the cloud. So, edge and cloud, edge will work as a complement of a cloud to reduce or to support the latency sensitive application for the devices. So, this particular challenge we are going to see how this particular model is going to address in the edge computing, in the realization of edge computing. So, in this lecture we will understand about the delay model to understand the requirements of latency sensitive applications in this environment, that is called edge cloud environment. Then we will also provide the analysis of main factors of service latency, that is considering both application characteristics and the edge cloud resources. Third important thing is the approach is to minimize the overall service time of the latency sensitive applications and enhance the resource utilization in the edge cloud system. Therefore, this particular aspect, which is called the computation of the delay through the delay model or a latency model, is one of the important paradigm in the edge cloud system architecture. Thereby, let us summarize what we are going to cover in this lecture. So, we are going to cover the edge cloud system architecture that includes the required component to support scheduling offloading task in the IoT application. That will introduce about the edge cloud system architecture, and this is the enabler for the edge computing. Second important thing which we are going to consider here is called the edge cloud. For the edge cloud system latency models we are going to cover, and we will show the impact of different task offloading schemes. So, maybe that you can design your own task offloading schemes, provided that it gives a better performance compared to the other schemes for time sensitive applications in order in terms of end to end service times. So, this particular model is good enough to measure the performance, and third thing is to measure or the performance measurement of different offloading schemes for latency sensitive application in terms of the service time requirements in these architectures. Let us get started in understanding about this important edge cloud system architecture. So, we will be explaining which through the figure which is on the right side. So, let us see that understand the figure first, and then we will explain in more details. In the figure, the first component is the cloud, and the second component is the edge. We call them as the edge nodes, and here we call it as a cloud. Now, between the cloud and edge there is a layer, sometimes it is called an edge layer. Here we call that what is there inside edge layer, we call it as edge controller, or sometimes it is also called the edge orchestrator. It has different components that we will explain. So, as far as this part is concerned, where the end user devices are there, for example, end user devices may be the smart CCTV camera or AR VR devices, smart CCTV camera, AR VR devices, online video gaming and other IoT devices. Other applications which are also using such applications are the smart or the smart transportation system, or some applications, or in the self driving car, or the robotics in the industrial IoT system. It can be any end user device. Now, every end user device are resource constrained devices. So, the data which is being generated out of them requires the computation. Now, this heavy lifting of the computation out from these devices may be either computed either at the edge or at the cloud. Now, how this particular aspect is to be decided, where it is to be executed, depending upon the service time or the delay model architecture, and that decisions has to be taken by the orchestrator, provided the resources are to be either provided by the edge or by the cloud. So, let us understand this architecture in more details. So, the edge cloud system architecture supports scheduling the offloading task of IoT applications in order to minimize the enormous amount of data transmitted in the network. So, this is one of the most important part, that how it is used to minimize this the data which is to be transmitted in the network. Meaning to say that if you have an IoT device or the connected device directly connected to the cloud, then this will be the network which will have the enormous amount of data which is being transmitted. To avoid this, so not all the data from the IoT will be sent to the cloud, but in between there is a system which is called an edge, called edge nodes, a system of edge nodes. So, the data these edge nodes are very close to the devices, or which are generating the data, they are called IoT devices very close by. So, obviously, this way it will minimize the enormous amount of data to be appearing in the network. So, the data will not appear in the network, rather it will be processed by the edge, which is very close to these particular devices. So, this edge cloud system architecture supports the scheduling offloading task of an IoT applications, and this is there to minimize the enormous amount of data to be flown or transmitted in the network. Next important thing is that having understood this edge cloud system architecture, how to decide whether the computation is to be carried out in the edge or it is to be in the cloud, depending upon how much resources is required by an IoT application, or depending upon what is the requirement of latency sensitivity in all such IoT applications. For example, if it is a self driving car, it cannot wait along for the computation. So, that is called latency sensitive application. Similarly, a smart CCTV camera which is doing the surveillance of particular let us say ATM machine. So, no one should be should take away or should hack the system. So, it has to be decided on the spot. So, this is also another example of a latency sensitive application. Similarly, the other type of application, let us say online video gaming, which requires a good customer or the user experience. So, for that these responses for computation and communication has to be minimized, and thereby this latency model is the guiding force of using this edge cloud system, and this is going to support different latency sensitive applications. So, latency models for delay analysis of different offloading schemes that explores the effect of computational and communication demand on each of these particular tasks. Now, that means, given this particular framework that is called edge cloud system, there are possibilities of different ways of task offloading, and this is called different offloading decisions within the edge cloud system. Now, if there are different type of offloading decisions possible, then you have to evaluate which one will be the best one for supporting that latency sensitive application. So, within that cloud can lead to the various service times due to the computational resource requirement, and this particular framework which we are going to discuss today can be automated further with the help of intelligence, that is AI and ML, on the task offloading issues, which is the point of discussion in the further classes. So, this particular framework will give you a good background about how the edge is going to be useful and going to be as powerful as the cloud, and thereby this particular edge cloud system architecture which we are now discussing is giving a way towards the edge computing to support latency sensitive application and also optimize various resources such as the bandwidth and so on. So, let us understand this particular important positioning of edge controller, because this edge controller has to decide among different offloading decisions what decision is going to be applicable for a particular application, and it will schedule the offload task offloading from that IoT for the IoT applications. So, let us get started in understanding about the edge controller, or often it is referred to as the edge orchestrator, which is very much an essential part of edge cloud system, or you can also understand that this is the heart of edge cloud system or edge computing system. So, let us get started. So, we call this edge controller orchestrator as EC, that is edge controller is the centralized component, and it is responsible for planning, deploying, managing application services in the edge cloud system. So, this particular edge controller often communicates with other component in the architecture of an edge cloud system to know the status of the resources in the system. that is whether the resources are available or not. If you want to know what you mean by the resources of an edge cloud system, so you have to now refer back to the fundamentals of a cloud, which says that the cloud provides the compute, storage and the network resources on demand. And two models are there, whether it is a private cloud or a public cloud, both of models are supporting in the cloud computing these resources. So, we have to understand the requirements of this particular resource. So, for that this particular controller has to have complete knowledge of the availability of the resources at the edge and so on. So, this particular statistics or the monitoring which is to be done by the edge controller. So, edge communicates with these particular system architectures to understand the status of the requirements, status of the resources in the system, that is whether they are available or they are being used, and the number of IoT devices which are using it, and the applications and their applications task which are running in the edge cloud system, and where these IoT tasks have been allocated, if let us say they are being used, whether it is in the edge or in the cloud. Complete information this edge controller keeps it to operate this entire environment for supporting different kind of applications. Now, the location of edge controller can be deployed in any layer between edge and cloud. One such important method or one such way of placement of edge controller we have shown in the previous slide. So, this is the typical inside view of an edge layer, which is called an edge controller. Now, let us see the edge controller has what are the following components. So, edge controllers has 4 different components. The first one is called the application manager, the second one is called the infrastructure manager, third one is called the monitoring, and fourth one is called the planner. So, here for example, this edge controller is acting as an independent entity in the edge layer. Edge layer means between the cloud and the edge, there is a layer where this edge controller operates. So, this edge controller manages all the edge nodes here and its control, and it is also responsible for scheduling the offloading task in order to satisfy the users and the edge cloud system. So, for example, if the user requires certain resources, so it has to now find out the availability, whether it is available at the edge. If not, then it has to be now serviced at the cloud. So, the application requirement and whether these kind of resources, the way it is to be computed in the edge cloud system, whether it satisfies the latency requirement or not, that is also very important, and the edge controller is responsible for all that things. So, edge controller is synchronizing its data with the centralized cloud, because if there is any failure and other edge nodes can take the edge controller responsibility from the cloud. So, that was the positioning of edge controller or the involvement of edge controller in bringing up the edge cloud system. Now, let us see the details of all these 4 components of an edge controller. The first one is called the application manager. So, application manager is responsible for managing the applications which are running in the edge cloud system. So, this is one of the most important, or the high level manager is dealing with the applications which are running in the edge cloud system or often using the edge cloud system. Now, application manager, which is responsible for managing the application running in the edge cloud system, includes the requirement of application task, that is the amount of data to be transferred, the amount of computational requirement, and the latency constraint and the number of application users for each edge node. All this information has to be managed by this entity inside edge controller called application manager. Now, second important entity is so you can also understand that this entity is about the application. So, knowledge about the application is managed by the application manager. Second important thing is the infrastructure. So, infrastructure that is called edge cloud system. So, about the edge cloud system, what resources it is available or being used by these applications is managed by the infrastructure manager. So, the role of infrastructure manager is to be in charge of the physical resources in the entire edge cloud system. For instance, the processor, networking and the connected IoT devices for all the edge nodes. So, this will become the part of the responsibilities of the infrastructure manager. Now, for that it is assumed that edge cloud system is working in a virtualized environment, thus this component is responsible for virtual machines as well. So, in this context this particular component provides the edge controller with the utilization level of virtual machines. So, this requirement of resources is again summarized in the form of the virtual machines. So, what kind of resources are allocated to the virtual machines which are using or which are running in the edge cloud system for supporting the applications. So, this utilization of virtual machines is also managed or maintained by the infrastructure manager. Third important thing is about the monitoring. So, the main responsibility of this component is to monitor the application tasks. So, this particular monitoring is all the time measuring on two different parameters. One is called computational delay, the other is called communication delay. So, this is the responsibility of the monitoring, that the application tasks how they are being using this computational delay and the communication delay at any point of time, and the computational resources, that is the CPU utilization during the execution of application task in the edge cloud system. Furthermore, the monitoring component of edge controller also used for detecting the task failures due to the network issues or shortage of computational resources. So, that is all becoming the part of the monitoring system. So, let me summarize that this monitoring is to monitor the application tasks in terms of computational delay and the communication delay and the computational resources during the execution of the application task in the edge cloud system, and also the monitoring will also monitor about the task failure due to the network or the storage shortages of the computational resources. Fourth important component is called the planner. The main role of this component is to propose the scheduling policy of the offloading tasks in the edge cloud system and the location where they will be placed. For example, whether inside edge cloud system, whether they will be placed in the local edge or the other edge or on the cloud. So, this particular planner is, after getting all these information available, that is from the application manager, infrastructure manager, monitoring manager, the planner will decide about this scheduling policy of the offloading tasks. So, this is most important part where you can think of applying the intelligence. The more this particular planner is using AI and ML system model, it is becoming as close to the peer, it will become the peer like the cloud system, and thereby this is growing the edge computing using this particular aspects. So, this offloading task works on this component and passes a result to the edge controller for the execution. Now, let us see about the latency sensitive applications, which we were talking about many times. So, latency sensitive applications have high sensitivities to any delay accrue in the communication or in the computation during the interaction with the edge cloud system. So, such high sensitivity to the delays, those applications are going to be supported with the edge cloud system, and they are called latency sensitive applications. For instance, then IoT device, when sends the data to the point that processing is complete at the edge node or at the cloud in the back end of the network, and subsequent communications are being produced by the network in the response to receive the result. So, take this example here, that self driving car consists of several services, and these services are categorized as latency sensitive, quality constraints and workload profile, that is requires the communication and the computation. So, for example, the self or the connected cars often uses some networking using, let us say, 5G network enabled enabling this connectedness of the self driving car or a camera installed within the car. This particular data need to be processed. It is a heavy lifting of the data to be done, whether the computation is to be done at the edge or at the cloud. So, that is what. So, if it is to be done at the edge to support the latency sensitive application. So, this particular latency sensitivity is going to be an important component here in deciding whether the interaction in the edge cloud system. Second important thing is that there are critical applications where the computational resources are very much needed in realizing the autonomous driving and the road safety applications. Another example about latency sensitive application is the high priority applications, which can be offloaded, but with the minimum latency, such as image aided navigation, parking navigation system, and also another applications which are called as a low priority applications in the latency sensitive category, which can be offloaded and not vital as high priority applications such as infotainment, multimedia and speech processing. So, having understood about the latency sensitive application, let us summarize the industries, what are the applications which are categorized as a latency sensitive application. So, if the industry is, let us say, industrial automation, then the application in the industrial automation such as industrial control, robot control, process control, they are all latency sensitive applications where this edge computing is very much needed. Another industry is called the healthcare industry. In healthcare industry, it is the remote diagnosis, emergency response and the remote surgery. All these things, if it is done automatically without manual intervention, then it requires, and they are called latency sensitive application, and it requires the concepts of the delay sensitive and the edge computing. Third important thing is the entertainment industry. So, immersive experience, online gaming and the driver assistance application are also the latency sensitive application in the entertainment industry. Transport industry, for example, the driver assistance application, autonomous driving and traffic management, they are all latency sensitive application. Finally, in the manufacturing industry, motion control, remote control, AR, VR applications are in the form of manufacturing industries. Now, let us see about the latency models for edge cloud system. So, the latency consideration for the edge cloud system is an essential step toward developing the effective scheduling policies and modeling various offloading decisions for the IoT task that can increase the quality of service, and which is very important in this latency sensitive application. Now, with the increasing number of devices, the amount of data which is produced in service time has been considered one of the most important factors in handling realizing the edge computing. Additionally, using the edge computing will enhance the application performance in terms of overall service time compared to the traditional cloud system. So, firstly the task allocation in the edge cloud system is not only done, but could also be on any of the edge nodes. So, moreover these edge nodes are connected in a loosely connected way, whether through the wireless networks, and making the process of resource management and offloading more sophisticated. This particular task offloading is allocated among multiple edge nodes working collectively and at the cloud. So, it is challenging to make this optimal offloading decision, whether it is to be done at the edge or it is at the cloud. So, what is that optimal offloading decisions to be made? So, thereby to guide this particular optimal offloading decision, often latency models are being used to investigate the delay of different offloading and schemes. So, these are the following offloading schemes. So, offloading to the local edge, and then offloading to the local edge with the cloud, and offloading to the local edge and other available edge and the cloud. So, there are 3 different ways offloading can happen here in edge cloud system, and the latency model will guide whether which of these different schemes or strategies of offloading will be useful for supporting that latency sensitive application. So, let us see these models one by one. So, they are offloading models. To understand the offloading models, we are now depending upon the latency models. So, the latency, we are going to see the first one, that is called latency to the local edge. That means, if let us say that offloading is done at the local edge or the cloudlet. So, we are going to see from the latency perspective with the help of latency model how much is the delay or the latency is involved in this realization. So, this is called the first level offloading system that is also offloaded, that means the IoT devices. Here you can see that these IoT devices, they are offloading through the network their tasks to the cloudlets, or sometimes it is called the local edge. So, this particular local edge or the cloud, they support the micro data center, and this micro data center is quite a small data center compared to the cloud data center. So, micro data centers are very close to the IoT devices. So, if let us say that one level offloading is done at the cloudlet or the local edge, which is nothing but the micro data center, and thereby this particular offloading can realize the computational and the communication delay to a minimum level, and it is acceptable if it is acceptable to the application requirements. Now, we have to understand that where this cloudlet or a local edge you will find out operating. You might have seen that if you have visited in a airport or in a shopping mall, you might have seen different coffee shops or a mall center, or let us say in the airport a lot of shops are there, and they often require a very high speed or high speed of computation, and all these devices which they are being used in the coffee shop or the mall center, airport, they are load resource device, they are also called an IoT device. So, I would say that if let us say that you have seen credit card machine called POS machine, that also is an IoT device. So, every mall will have, at least every shop will have more than one such IoT device. So, you can see that the mall will have these IoT device, and these particular IoT devices, they often depend upon the edge computing for task offloading and doing all kind of computation in the form of so therefore, this is quite reasonable model, and lot of application around you are depending upon this kind of model, where task is offloaded to the local edge or a cloudlet. So, here the IoT device can offload their task to be processed on the edge or on the cloud as an example. So, this offloading scheme provides an ultra low latency. Why? Because here the cloud is not there, and it is a micro data center which is very close to the IoT device. So, thereby this particular model, if it is effective to give the resource, to provide the resources to the IoT application, then it will achieve the ultra low latency due to the avoidance of network long haul delays. The end to end service time, if we see in this particular model, that is the latency to the local edge or a cloudlet. So, it comprises of two kinds of delays. One is the network delay, and the other one is called the computational delay. So, this is called the network delay, and the other is called computational delay. So, the network delay, if we see that it consists of the time of sending the data to the edge. For example, this IoT device takes the time through the network to send the data to the edge. So, this is called the network delay, and the time to receive the output from edge to the IoT device. For example, when the IoT device is ready with the data, so it has to now send back to the IoT device. So, this is again a network delay. So, network delay is sending the task from IoT to the edge and from edge to the IoT. If you add that, this will become the network delay, whereas computational delay is the time from arriving the task to the edge nodes until the processing is complete. So, this is the delay in doing the computation. Therefore, the end to end service time latency in this model is the sum of the communication delay and the computational delay, which is expressed over here. So, latency in a local edge with a local edge or a cloudlet is expressed as the time, transmission time between IoT device to the edge node for uploading, plus the transmission time between IoT to the edge node for downloading, plus this one, that is called the computation time in the edge node. So, this particular component is called the network or the communication delay. The other component is called the computational delay, and the total latency is the summation of computational delay and the local delay, which is expressed here in this particular equation. Now, let us change the model here. Other than local edge, you have the cloud also. So, let us see that you have an IoT device which is directly connected to the edge node, and the edge node is connected to the cloud. So, this is called local edge with the cloud. So, this is the local edge with the cloud and IoT device. So, if you also include the cloud here, let us understand about the latency model and what are the latency sensitive application can be supported under this particular latency model. So, this offloading scheme rather relying on only one edge node. So, here we assume that there is only one edge node and the IoT task can be processed in a collaborative manner or cooperative manner between the edge and the cloud. Now, this particular way has the advantage or the benefit of both the cloud and the edge computing. Here the cloud has the massive amount of computation resources, but it has a lot of latency, whereas the edge has lower communication time, and thereby it will reduce the latency. So, this combination of edge and the cloud is going to be useful in realizing the latency sensitive application. Now, once the cloud finishes the computation, it will send the result back to the edge, and the edge will send it to the IoT device. So, let us understand the end to end service time under this model, which is local edge with the cloud. So, this has two types of delays in the end to end service time. One is called communication delay, the other is called computation delay. So, let us understand about the communication delay. So, the IoT device when offloads the task to the edge. So, so the time between the IoT device to the edge nodes and the time between the edge node to the cloud. So, this is one such time, that is when IoT device will offload to the cloud. So, this particular delay, and when edge node then offloads it to the cloud, that is another delay. So, this is called communication delay, communication time, and then once the results are ready, then again the reverse communication has to happen. So, the results can be communicated back to the IoT device. Second type of delay is called the computational delay or the computational time, that is the processing time which is required. For example, if let us say that the computation is done at the edge. So, that particular time for the computation called TCE, here you can understand the computation time in the edge node. So, that is one factor which is being added in the complication. The other is that if the computation is done in the cloud, then you have another delay. This is called computation at the cloud. Called TCC. So, these will form the computational delay, while as remaining becomes the communication delay. So, communication delay components 1, 2, 3, 4. So, this is one component, then 2, then 3 and then 4. So, overall delay, that is called the latency in the local edge with the cloud, is expressed here in this particular equation. Now, we have the most generic model where you have the multiple edge nodes. One is direct connected to the IoT edge, and then this particular edge node has also connectivity with the other edge nodes, and this edge node also has the connectivity with the cloud. So, this model is very generic, where it has the multiple edge nodes. So, this will become the multiple edge nodes and with the cloud. So, earlier slide we have shown only one edge node with the cloud. Now, we generalize it to the multiple edge node with the cloud, and in this model let us understand the latency and see that this is very generic model, how the latency sensitive applications are going to be useful or using this scheduling or offloading scheme. So, it is called a 3-level offloading scheme, aims to utilize more resources at the edge layer and supports the IoT device in order to reduce the overall latency. So, this edge layer will have more than one edge nodes, and thereby it will reduce the overall service time. Now, this adds another level by considering other available computational resources in the edge layers. So, therefore, this end to end service time is often composed of the communication time and the computation time. So, communication time is the time between the IoT device to the edge node, and the time between the edge nodes to the other edge nodes, to the other collaborative edge nodes, and the time between the edge node to the cloud. So, there are 3 different communication delays are involved in this generic model, which contains the multiple edge node with the cloud. Whereas, the computation time required here in the edge node, that is mentioned over here, and the communication time which is required in the other edge nodes, which is mentioned over here, and the communication time required here in the cloud. So, these 3 components will become the computation time, whereas the communication time, if you see that communication between offloading between IoT device to the edge node is called this particular uploading time from IoT device to the edge nodes, and then from edge node to the other edge nodes, this is called uploading time from other edge node from the edge node to the other edge nodes, and then uploading time from the other edge node to the cloud, from the edge node to the cloud, that is what shown over here. And then finally, the transmission time in a reverse direction, that is from the cloud to the edge, and that is called download time. Similarly, between the other edge to the edge node and from edge node to the IoT. So, this becomes 3 level offloading scheme, and we have seen the end to end service time requirements in this particular model. So, this is most generic model. If you understand this particular model is quite flexible in terms of giving more resources at the edge layer, thereby supporting a much wide variety of latency sensitive applications, whether it is self driving car or maybe some other type of resources. That means, in the first model we have seen that from IoT devices to only one edge node is very limited, and the scenarios like it is a mall or it is an airport where multiple devices can be served or can be very fast. The second important thing is that we have now added cloud to the edge node, and thereby we have added the capabilities more to it. And then finally, it is multiple edge node with the cloud, thereby it is very generic application, very generic model which can support large variety of latency sensitive applications such as self driving car or smart CCTV camera monitoring. Now, let us conclude this particular discussion of this particular lecture. What we have covered are the following. So, first thing is that what we have seen a generic architecture to support the latency sensitive applications, and that architecture is called edge cloud system architecture, and this is a very fundamental stepping stone in realizing the edge computing. So, this edge cloud system architecture includes the required component to support the scheduling offloading task of an IoT applications. Now, the next important thing which we have seen here under this particular architecture is called the edge cloud latency models, and this particular latency model will have the impact of different task offloading and scenarios and the schemes, and which of these particular task offloading schemes out of many for supporting the delay sensitive application, the guiding principle is the latency model and in terms of end to end service time. Now, finally, the calculation of an offloading latency models that consider the communication and the communication delays as the key parameters with respect to offloading to the local edge and the other edge or to the cloud. So, all three different aspects in realizing the edge computing framework we have covered here in this particular lecture. Thank you very much.